left off in our last session. Anyone? Hi Ravindra, hi Avinash. Hi Ravi, Likita, sorry. Have you been joining the sessions, Likita? I don't remember. So in the last class, I have given you a couple of things to do where I asked you to, hello, someone just left, where I asked you to revise all the things that we have covered till that day or that session, and you have to write all the notebook code that I have shared on your own and do some hands-on experiments with it. Did anyone do that? No one tried. All right. Did anyone remember till what we left off in the last class? Anything if you remember? No?
Hello, Nikita Avinash. Are you in session or sleeping?
Ravi? Ravi, you can just mute yourself. There is too much noise from your side. All right. Let me just quickly start. Okay. So we were looking into word to vec model, right? And we understood how we can develop this model. What is word to vec? Word to vec is nothing but representation of words into a vector form where we saw the old techniques, the traditional ones, right? Which was a frequency based techniques. Now we looked into word to vec, which is a kind of neural network model which tries to learn about the words and their semantic meanings, right? And this word to vec model was developed by the Google researchers in 2013, right? So what it is a neural network model that attempts to explain the word embedding based on the text corpus. So if you remember, we have seen a Google model, we have also seen the dimension of it, I'll quickly walk through the notebook also, and then what it does is based on the context or based on the words that are there in that particular corpus. We what we try to do, we try to learn its meaning, learn the meaning of those words based on the words that occur in that particular sentence or that occur together. Okay, it looks at the nearby words, right? We have seen something like that. If a group of words is always found close to the same words, they will end up having similar embeddings, right? We have also seen the example of a handcrafted vector, right? So if you remember uh, this part of the thing in the lecture where I have taken king, queen, man, woman, and monkey. What we did, we tried to give some features. We handcrafted these features, and then we tried to construct a word to vec. What is this? This was a word, and using these features, we constructed a vector for them, right? And then we also have seen that how king, monkey, and this vector was constructed, and how king minus man when we do this particular operation, whereas I minus the man vector from the king vector and add a woman vector, what we will get, it will come something closer to the queen vector, right? Do you guys remember this part of the thing that we have covered in the last sessions? Anyone? Okay, then we have also seen two main techniques of building or training a word to wake model. What was those? One was the CBOT technique, right? One was CBOT technique, and the other one was skipgram. Now, both of these techniques are nothing but what? A neural network. Both of these are what? These are neural network techniques based on which we will be able to construct our what to pick. Now, what does that had in the keyboard technique? We had some window size, then we used to construct, right? If you remember, we constructed a training data set wherein our y was what? Y was the middle word from the context window, and x was what? X was their vicinity or the remaining two terms of that particular sentence. So if you remember, the cat sits on the mat. We took this example, and what we did, we tried to construct this data set. How did the data set for CBOT technique look like? In that, every window we constructed what window size. What was our window size? Every time the window size is of 2k plus 1, right? And here in this particular example, what we did, I took a k is equals to 1, which brings my window size to be what? 3, right? Now, now when I did that, window size of 3. So cat sits on. This is my first example of the training set. Now in CBOT technique, what I will do, I will write the middle word as the y, right? That will be my y, and the words in the context or around the sits word in the window will be my x. So cat and on will be x and sits will be y. So what is the CBOT technique? We are trying to do what? We are trying to solve a dummy problem which says what? I am constructing a text to word, text to vector, and it is what in byproduct will be what? I will get the embeddings of those words. Given the context words, sorry, given the context words, trying to predict the target word. Now here, what are the context words? Cat and on, and sits is the target word. Then in this, sits on the, in this example, on is the middle word which will come out to be as target word, and sits and the is the sits and the is the context. Again, on mat is my context word, and the is my target word. In this way, then we converted it into one not encoders, and then we feed it to what? We feed it to a neural network. And as a result, when I give these two input, right, each example will be fed into the neural network. This will be a weight matrix here which you are seeing, and then what it will do, we will have a softmax function which will predict the probability of the occurrences of these particular words, right? And once one iteration is done, what will happen? The losses will be back propagated. It will then again modify or change the weight matrices, and again we will do, or we will train this particular neural network for some number of epochs. Epochs, if you know some of the machine learning or deep learning techniques, epochs is nothing but the number of times we train a neural network. It is an iteration where the weights are minimized, and then we try to do the back propagation, and then we change the weights and the ideal, until we say that the loss has been minimized completely. Okay, so as a result, at the end, this particular part of the uh, what we can say neural network, here 3 cross 5, this will give us what? This will give us the embeddings for each word. Okay, this was what? This was the CBOT technique, right? Continuous bag of words. And there was one more where we saw skip gram. Okay, so skip gram, where is skip gram example? Just checking. Yes, this one, right? So what was the opposite of CBOT technique? CBOT technique as opposite to the, here in the CBOT technique we were taking context as our input, as our x. In skip gram, the context is our y. Okay, what was the difference? In skip gram technique, our x was the target, sorry, our x was the middle word in the window, right? Cat sits on the mat, right? In this example, the middle word is what? Middle word is my x, and the context is nothing but my y. So these two words I have to predict. Okay, now in this way again we will train the neural network, and then we will eventually get the embeddings of all those words. Okay, this is till now what we have covered, right? Now, right, so all of this continuous bag of words and skip gram, these were the two architectural variants of word to vec. Then we have seen again what is the in CBOT technique. The primary task is to build a language model that correctly predicts the center word. Okay, so here what it has to do, it has to correctly predict the center word, right, given the context word in which the center word appears, right? Now this is how we constructed. In the similar fashion, we also took one dummy example and we have solved that, right? Now, this was the neural network, skip gram. Now, how does the skip gram look? Similar to CBOT technique. What are the few changes? The task is to predict what? The context word from the center word. Uh, what is the objective or goal of the skip gram technique? We have to, the task is to predict the context word given the center word. Okay, the task is to predict the context word given the center words, right? The task is to predict. I am repeating again and again because it is very important. What is our task in skip gram? The task is to predict context words given the middle word or the center word. Okay, now this is how the architecture on neural network looks like. If you see here how it is now one word is my input, and I want to predict in the output layer more than one word, right? That's why here we have y1 y2 j, like that. Okay, all right. Now, in this process, we had some hyperparameters and selection. How do we select our model, right? And some of the few things to note of. Now, what was that? Now, here, what we understood, there is this parameter where we have a window, right? K thing, where we understood that is the context window. How many words together we have to consider while constructing this particular model. So, what is one of the dimensionality of the word vectors? As the name indicates, in this particular embeddings that we are learning, we how does this dimension depend on this dimension? What? Yes, this particular weights, this will give us eventually my word embedding. So this is one of the things that we need to keep in mind. What? That the while there is no number, like while there is no exact number, how will be the dimension of my embeddings decided, but based on the range, like it is usually in between 50 to 500. And if you see the large language models that have been constructed, 1 second. Yeah, so in other, now the big models, that GPT models and all those models, they have a large dimension, right? We know that they have been trained on billions of parameter, and therefore their dimensions, the embeddings dimension is more. But when we started initially, it was within the range of 50 to 500. Okay. And now context window, how long or short the context window we look for to learn the vector representation. Okay, so this is also one of the hyperparameters that we, so these two things, the dimension and the context window, these two things are the hyperparameters that we need to decide. It can be based on anything, based on the use case, or based on the results that we are trying to bring out. It can depend on both of those things. So there is no direct number, or let us say the context window should be of size, let us say 10, 20 or something. No, that we have to decide based on the application. Is that clear till here? This was a quick revision that we did for the other last sessions that we have done. Okay, any doubts still here? I hope till here everything is clear. Skipgram and Seabout techniques for creating a word-to-vec model. Okay. Now, can you see my Visual Studio Code? Is it clear enough for you? So I have all, like today I don't have two screens, so I'll have to share in this way. Now, guys, before I start this, I just want to understand. I have asked you to write all the old notebooks. If you see, I have shared all these previous notebooks with you. Have you all taken some time and wrote, or just recreated your version of these notebooks? This was the homework from your last session that I have asked, and also I have given you some assignments. If you remember, these were the two assignments, like one was the IMDb Kaggle dataset, and another one was the coronavirus tweets. So we have to do some basic visualizations and some pre-processing techniques that we have learned. Has anyone did this? At least share your screen and tell me what is your doubt, or where you have not been able to do if you have not done. Because all the notebooks I have already shared with you. If you guys remember, I have given you this task of creating your own NLP folder and adding all the notebooks that I have shared with you. Can anyone share your screen and show me their NLP visual code folder where all of these assignments and notebooks that I have shared is been created and you have been using it? If you're not saying anything, means it, I will consider that your answer is no. Can anyone share your screen? No one can share. All right, then let me just move forward. Okay. So this was one of the thing that we have already seen. So what we did, we downloaded one Google News what to wake model, right? I can just quickly show you the running code. So if I just see, this is what this we are using GenSim package. This is one of the NLP packages that is widely used, and from that we are importing what to wake. Okay, so from the models in GenSim package, I am using the word to wake model. Okay, and in that word to wake, what is word to wake is one of the types of the models. Now, in word to wake, there are different types of models, right? One is fast text. Now, based on their name, it suggests what it will suggest, who developed that, and on what corpus it is developed. So if you see, fast text is this is also one of the other packages that we can use for NLP things. Okay, so now if you see this particular output, what does it say? Fast text wiki news subwords, and after that it is written 300. Now this is a fast text model trained on Wikipedia news of subwords, and the dimension of each vector or each embedding in this particular model is 300. So if you remember this particular vector, right, this the dimension here, it is of 300. So with the help of 300 numbers, real numbers, it will be constructed in the form of a vector, right? Now concept net, number batch, another one, supervisor, sorry, what is this? What to wake, Rus Corpora 300, again what to wake, Google News. So this was the first model. Okay, this what to wake, this one Google News dataset, this was the first model which Google scientists have trained when they were working on what to wake technique. Okay, and in its domain, like in what to wake thing, this was the first model developed by Google, and it was used, and sorry, and the training data that they used was what they used, a news data set. And what was the size of the particular embedding vectors? That was 300. Now glove is another one, so I also have showed you. So if you remember, this is fast text. Okay, fast text is there, glove. Okay, so what are these are again what open source free lightweight libraries that allow us to learn text representations and text classification. So similar to what to wake, again all these are what, these are different packages. So okay, so glove like Jensen, glove, fast text, this is again GLOVE stands for Global Vectors of Word Representation. Okay, and just like what to wake, we have different what to wake is trained, or the architectural variants of what to wakes are what, skipgram and uh, CBOT technique, right? On similar lines for glove also, global vectors, this also has some, as its name suggests, so this is a kind of unsupervised learning, and here the corpus is trained on not just the co-occurrence words, but the global matrix is considered here. Okay, so you can just take a look at that also. Okay, so glove again 50, wiki gigawatt 50 is again what, the number of the dimension, again 100 is the, again same model, glove wiki gigawatt 50, glove wiki gigawatt 100. What is the difference? This embeddings, each vector is of what size? Each vector is of size 50, and the other one, each vector is of size 100. 200, 300, 25. This is on Twitter dataset. Okay. Now, so let me import another model. Okay, Google model. So I am just importing Google model. Right. So now I have downloaded or loaded from the API the Google model, right? And I'm again loading this. If you see now, what is key to index? These are the number of words, right? These are the number of words. Is my screen visible, guys? Correct screen, right? You can see the notebook. All right. Now, in once I load the model, what I am trying to do, let us just see king. Okay, for the same king word, what is the top 5 similar words to the king we can get from the Google model? Now, if I execute this, so most similar word, each of these models have some predefined functions attached to them. Okay, when they were developed. So most similar, some will give you some, there is this most similar does not match, or one is, so get the vector of this particular word. Okay, so what does this most similar will do? It will calculate the cosine similarity between these vectors, and it will give us the top 10 similar words to those particular or that particular word. Okay, if you see king, kings, queen, monarch, crown, prince. So these are the words that occur together or that are nearby to what, that are nearby to the king word. Okay, I hope this is understood. So if you remember this part from our board, so these are what, these are nothing but, these are nothing but vectors. Now king and queen, so because of their function, because of their what we can say, features, understand the semantics, like king and queen are somewhat healthy, wealth is there, they have some power, something the model has learned. These features we don't know, but they can be represented like that. And when the Google model was trained on the corpus of some 3 lakh words, it understood what it understood, that with the king word, queen, monarch, these are the very much similar words. They appear together, or they are in the vicinity, or they are nearby to the king word. That's why these have the same vector, like somewhat same vector or similar vector, and not much difference is there in those vectors. Okay, so if you see now this vector, what is the size of this particular vector? So in the Google model, what was the size? It was of size, it was of size 300, right? Each vector, each word was a vector of how much dimension? 300 dimension. Okay. Yes, this was there. Again, Google model shape, beautiful, right? Beautiful. Now, I gave you an example, just like what we saw for the king minus man plus woman is equals to, or the vector is near, somewhat similar to what, queen, right? In that way, here we have taken the example of, let us say, currency of India minus, I am doing India. So from the currency, I am subtracting the model of, sorry, the vector of India, and I am adding the vector of USA. So it should give me the currency of USA, right? So we just see. So now if you see, oh, even though here INR is in the first, but ideally, what is the answer? Euro is the answer. Euro is the answer for this particular vector, right? Now we see the beautiful example. Now this is how the vector for beautiful looks like. Again, this new vector, king, same example. I am using the king vector. I'm subtracting man and I'm adding. Now from that, I'll just to see. So what we are getting? So to similar to this vector, what are the related words I am getting? These are with the woman. Sorry, this is what this represents, mostly queen, right? So with queen, what are the similar vectors? So this is king, queen, monarch. All these are coming. Okay, so if you see in this particular example, king minus 1, what is the similarity score and what it gives as a result. So again, most similar, this positive, this is another way of using the word to vec. So if you see here, I used directly the vectors from the model, and here I am using the most similar function positive. I have to add these two vectors, and negative I have to subtract the man vector, right? In this way we can do, and if I just print the result, it will give me queen and the similarity score. Okay, this we have already seen. Now just can you just try you creating this on your own? I can. Are you using laptop with you? Does anyone has laptop? I have already shared this. Can you just show me if you have executed this particular what to work example notebook? Are there any difficulties in this? Guys, can you just let me know if you have executed the word to work notebook? If at least one it has done, it will be good for me to understand. Okay, at least one person is doing. Who, Ravi, or I don't remember, Sai Kiran. Someone shared the screen last in the last class. Who shared the screen in the last class?
It's me, ma'am. Manu.
Okay, Manu. Have you created? Have you created your own because you shared a Google Colab notebook, right?
Yes, ma'am. I created my own in BS, ma'am.
Okay, VS Code, you have created your own notebooks.
Yes, ma'am.
Okay, can you share your screen today?
Actually, I'm facing a issue laptop, ma'am. That's why I'm just fixing my laptop now.
Okay, what about others? Kishore, Ravi, Avinash, Sai Kiran. At least if you should show me something that you have executed something, otherwise it is difficult for me to move forward. Every time I cannot just keep on teaching and you guys don't execute any of these, or I am sending you the notebooks what I have created. Kishore, what about you? Are you there, Kishore? Uday sir, are you there? I don't know if he's there. So no one is in the situation or circumstances of sharing their screen, right? Okay. Okay, then fine. Let me move forward. And now this time I won't share the notebooks. Okay. If you want, you can take 5 minutes and just copy all of these one by one from here, and then you can paste it, like just write all of the code from the screen. If you want, I can wait for 5 minutes. Just let me know, or else I can move to another notebook that I have to take for today. Are you guys writing this code in your laptop now, right now? or you already have, because I remember I have shared this what to work notebook also. So fine, let me move forward. Okay, so if you see, we have just seen these two techniques. Now, out of these two techniques, one of the techniques we will try to learn, as in we will try to code it. Okay, so we train our own what to work model on some data set. Okay, so I have taken this data from Kaggle. Okay, so I can show you. Okay, so this is the Kaggle platform where I have taken this Kaggle Harry Potter books. So you might have seen this Harry Potter series, all the parts of Harry Potter from that. This is the Harry Potter. Now this is in the form of book. Okay, each of the part of this particular series, here it is in the book. So if you see book 1, book 2, all this is in the text format. Okay, I can show you what I have. So here you see the first book. Okay, the first whatever it was. So this is all the complete each and every we can say event, or as it is with the conversation, this is there in this particular book. Now what we have to do, we are taking this particular data set, and we are trying to train our own model. Okay, what we are trying to do, we are trying to train our own model. Now in my data set, so if you see, I just imported the gensim package and the also operating system. Right now I have imported these packages, and what I am doing, I am importing the and I'm importing what, and I'm importing all of these three text. Let me just check. Um, yeah. Yeah, so if you see what like this, it should be. Okay, so these many words are not there. So I can just do it. Mhm. Let me just do small. Okay. Ah, why is that happening? All right. So these are the first 1,000 words. Okay. Consider these are the first 1,000 words from the book. Okay. Now what we are doing, what is our typical process? We do some pre-processing, right? We get the data that we have loaded from what? We have loaded this data from the text file, right? And from there we will take, now if you see, these characters are there, right? All these characters are there, these backslash and few more like these commas and all these things. We have to use the simple pre-processing technique, and we have to remove that, and we have to use this particular data set for training or creating our own word to vec model. Now from gensim, there is one package which has this simple pre-process. This simple pre-process function, what it will do, it will do, I'll just tell you, convert a document into a list of lowercase token, ignoring the tokens that are too too short. Okay, so it will return us the simple preprocessor, which will just convert the document into a small tokens or shorter tokens. Also remove the characters somewhat, all these commas and some basic pre-processing it will do. Okay, so once I do that, if you see, also I have removed the stop words. Okay, I have also removed stop words from here. So if I execute, okay, so if you see, few of the things that I have removed and I have got this. Okay, so these are not sentence transformation. Okay, so each this is one particular sentence. Okay, so now in the first sentence it was all removed, nothing was there. Now Harry Potter was birthday, first time, argument broken, breakfast number 4, private drive like Mr. Okay, all of these are what, all of these are sentences and their tokens. Now how many words are there in this? Now in this total corpus, I have used 3 books, right? There are how many books? 3 books are there. So what are the total number of words? Length of the word 17,000. We will see unique also. Okay. Till here, everything is old things that we have already seen, right? Now we did simple processing. We loaded the data set, right? So I can just write here. So here we do what? Load data set. Okay, then what we did, apply basic pre-processing, right? Okay, now we applied basic pre-processing on the words. Now these are the these are the filtered corpus words 17,000. Now what we have to do, we are trying to train this particular model on our data set, which is what, which is Harry Potter data set, right? Now what we do, we will call GenSim models word to vec. Okay, we have done this here also. So we called what, here we loaded, but here from GenSim we are calling the word to vec model, this one. Where is word to vec? Yes, this one. Okay, and now what I'm doing, I'm giving what, I'm giving the window size of 10. Okay, so when my word to vec model is trained, what is my window size? 10, right? Now window size is 10, meaning k, 2k plus 1. Now minimum count 2. So what will be the minimum count of the word? Should be 2. Number of workers, this is again one of the vector size. Now this is important, this we have seen in our slides also. If you remember, we have seen here dimensionality. This is what our hyperparameter that we need to set. So that is nothing but the vector size. Epochs also I have already told you. Now let us just do this to 50. Okay, for now I am just changing to 50 and epochs is equals to 10. Now I am building a vocabulary. Now if you model dot build vocab, build vocab is another, again this is a function that we have in our model. GenSim models what to vec. What it says, Harry Potter corpus filtered. So I am building this vocabulary on my which corpus? Harry Potter corpus. Okay. So once I just execute this, I already built it. And now if I count the number of words, how many words are there? 17,956 words. What is model dot epochs? Will give me the number of epochs. Okay. Now using the train method, using model dot train method, training on what, this particular. Okay, as my corpus has increased, let me just increase the vector size to 100 itself. Okay, so total examples, whatever is the count, and model epochs is equals to 20. So now I don't know if, so it will take some time. So my system has a good configuration. For you it will take an 15-20 minutes, depends on your configuration. Okay, your system config. Now if you see what I've just tried, so we don't know how much well it has trained, but still I'm just trying to print this. So Harry again, all the words that were coming with Harry are coming here. Okay, now let me just see. Dursley was their this uncle auntie's surname, right? So if you see Fig, so now near Dursley. Now if you see Fig, Norris, Borgin, Ollivander, Weasley, official husband, Red, scrubbing. Now if you see this Fig and Mason. Now if I go back to here, so So see, Dursley. Now near Dursley, if you see, there will be some words related to Dursley. Now let me just see. There was some description of it. You see, Mr. Fig, right? So all of these words were coming together with Dursley. That's why it is coming with Dursley. Mason. So this was from, maybe this is from this book. So you see, this is Mason's, right? Again. So these are few. So we have to train it based on the accuracy. So once we are satisfied with it, we can move forward. Okay. So most similar is, again we are calling model dot wv. Now wv is nothing but the word to vec model, and from there I am just calling the most similar function. Okay. What else? Now most similar will give me for one particular word. It will give me the similar words to it, right? If I give two words, it will give me what is how much similar they are. Now, if you see, Harry and Dursley are not similar at all, right? Now, let us just check with Harry and Ron. You see, this was this should not have been negative though, but we are using big corpus, so I'll just check. Now if you see Harry and Ron, what is the similarity? 20.07. Okay. Now if I want to see the vector of Harry, this is how the vector of Harry looks like. So if you see, what was our vector size was 100. Okay. Now, what else we have? Now get normalized vector. This is also fine. Now the shape of the vector, you see, now we have what? The shape is what? 100, right? Like, and total words are 36872. Let me just check about this. Yes, if you see, so total number of words, what do we have is 6872, and each word is of what shape? Each word will have some 100 different types of numbers here, like each word will be constructed in that form. Okay. Now, I have just tried creating some few visualizations also for you. So let us just see. This was long back I created. So do you guys know PCA? So now we have a vector of what size? We have a vector of 100 dimension. Is it possible for us to view that 100 dimension vector in 3D or 2D space? No, right? We don't have that capability. So it will be like not possible for us to visualize those 100 dimensions vectors. So what do? We reduce the dimension of that particular vectors, right? To visualize them, and we create in such a way that we will be able to visualize. Now, PCA is principal component analysis. You might have learned in your machine learning thing, where PCA, what it does is that it is a dimensionality reducing technique. PCA, principal component analysis. What it does, it decreases the dimension of our data. Okay, so here what we are doing, from 100 to 3, we are changing the dimension from 100 to 3 components. Here components is equals to 3. So now if I try, I'll just see if it gets executed. One second. Okay, I just okay. Now see, whatever we have in our model, right? Y are the name of the words. Okay, if you want, I can print Y. So y are nothing but the words, and x is what? X is their transformed vector. Now if you want, I can print x also. So I can just print here x, and you see these are all the transformed vector. Now each word, this word has been transformed into a vector of size what? 3. So 3 components. Now this is the representation of word Harry in what? In the 3 dimension, right? So there should be somewhere Harry here. So see, Hagrid, Harry, Malfoy, Snape. See, all these are coming together. These are the first words. Okay, secrets of secrets professor. Okay, there is secret Rowling. So what is Dumbledore is also there. So these are the few first 40 words from the book or from our corpus that I have tried to put it in the form of graph using what PCA. Is it understood? So it's nothing but just a visualization. What else? Azkaban, prisoner. See, Azkaban and prisoner, these two words are coming close to each other. Why? Because they are what somewhat similar, right? The context for both of them is similar in our corpus. That's why they are coming together. Their vector is coming together, right? Okay. In this particular thing, what we could have done, one more thing is we could have removed these verbs also: going, got, go, said, think, will. All of these also we could have removed, and we could have just kept a few important words like the nouns and somewhat maybe adjectives or something, but this also looks fine. Mhm. Chamber, you see, chamber, stone. If now these are, imagine these are just 40 words. Now still they are able to see Hagrid and Harry and Malfoy. All these three or four people are coming together. Now I think this is, I don't know if this is Hermione and Lupin. I just think so. Ron. These are coming together. So still Ron should have also been came here, but it is little bit far. So it depends on training, like we need to train so that we can understand how good it is giving us the similarity matrix. Okay, all right, now this was using matplotlib library. Now if I want this, also this is a 2D representation. Now how do we have a 3D representation? I'll just show you quickly. So here this is using Plotly library. Okay, so I can, second, same words. I'll just remove all the, okay. So you see all the different words. Okay, so now you see Hermione. I don't know why it is not getting zoomed in. Otherwise, it had the capability of. Okay, now we can see. If you see, this is Ron and Hermione. You see, they are very, very close to each other, right? And here we see Harry. This is Azkaban, prisoner, Potter. Again, all these are very, very close to each other. Now, this was what? Here it was a 2D representation, and here it is a 3D representation. So, okay, I can just. So now, if I. Yes, now you can see it more properly. Right? So you see now all of these are coming proper visualization. All right. So this is about visualizing like how we can Snape and Lupin. You see all professors, like all of these are coming near what somewhat close to each other. Okay. Now this is one more. What is this? Using Plotly. This was 3D. This is like 2D. Okay. This is the 2D representation. Okay, so again, same words, 40 words, and we are trying to represent it using uh, 2D, using Plotly. Okay, is it understood? So these are all you can just write using your on your own. This is just for I tried for you to show the visual representation. Okay, now. Now what you can do, just try writing this notebook on your own. Like if you want, you can take some 5 minutes and you can just write this part of the notebooks. I can share you the data set. One second. Okay, so I have sent all these books. Just download them now, and once they are uploaded, all right. So please download this. Once it is downloaded, please please write this code. If you have any doubts, you can just ask me. I'm here. Okay, please write this and share your screen once you have written it. Okay, or just you can ask me to move the scroll the window. Guys, are you here?
Yes, ma'am.
Okay. So can you just copy the code, because I'm not sending the notebook now. Unless any one of you shares their notebook with me, share your screen. I won't be able to share the notebook, okay? Because this is simply copy paste. So instead of that, we have time. So please write this code by yourself from the screen. I will wait and then we will move next. Okay? I have shared you the this thing also, books, textbooks, the data set, right? We have the data set that we are using. I have shared you over the chat. Please download it. You can use one also for now. Just try it for with one book, and then we can you can try with the other two also, and I can share. Uh, All right, please use the three notebooks. Sorry, three. What I sent, three text files. Can you confirm if you have downloaded the text files? Have you downloaded the text file, guys?
Yes, ma'am.
Okay. So please start writing this code. If you have any doubts, please ask. I can explain again. Okay. Once done, please let me know. Are you guys writing?
Yes, ma'am. Yes, ma'am.
Okay. Thank you. Let me know if you need the next part. I can just scroll up. Okay. I can hear you. And I can just update it, like move the notebook. Manu, once you are done writing the code, please let me know and please share your screen. Okay. I hope that works for you.
Okay, ma'am.
Okay. Thank you. So the first thing, we are importing the Gensim package and the OS model, okay, or module, not model, module, and then we are loading the data set, right? So from the list directory function, we are giving it the path to the data set. So you have to create the data set folder. From inside that, you can add the folder name and all the text files that I have sent. You have to add it in that particular folder. For now, what you can do, what I can do is, we can simply use, let me just move it. So you can just use the first book. Okay, you can just simply use the first book. I can show it to you again. Mhm. Okay, so hmm, okay, so this also can go here. Okay. So I'm just using one book because we don't know what is your system configuration. Let's use only one book. Okay. So I just load that data. So this is only first book. I am just loading it. You see all the uh, data from the first book, first 1,000 words. Now we apply the basic pre-processing. So from the tokenized NLTK, this we are using what tokenizer. Why? Because we have a book and in that we have sentences, right? Because it is a book data, because and not a any other kind of data. So we are doing sentence transforming. What will happen? Sorry, sentence tokenization. So each of these sentence will be converted into a sentence token. That's why when we saw this is our sentence tokenization, and that's why here this complete is one sentence. And if you want, I can just show you in the book one. So the first sentence, right? Okay. So the first sentence, where it is starting. Let me just see again. So once I do, okay. So we did this, right? And the first 10 sentences, right? So boy lived Mr. Mrs. Dursley, right? So if I go Mr. Mrs. Dursley, four boy lived. Where is boy lived? Right? Boy lived Dursley number four. So all these sentences, right? So four private drive proud say this is the first sentence, and all the stop words or tokens they have been removed, right? So just write this part of the basic pre-processing that we are applying. Manu, have you completed till here? Did you understand this part? And also directly, so if you remember, we did this simple text pre-processing, text representation, right? So instead of that, we are simply using the simple pre-process function from the gensim libraries from utils folder as in that module, and I'm just importing this simple pre-process function. You can use your own other from NLTK also. Okay. So once we apply that, my corpus will be filtered. Okay. So all the stop words, if you see here, English stop words have been removed. So A and B, all pronouns and all that stuff have been removed. Okay. So this part will give us the basic pre-processing. Manu, have you completed till here?
Yes, ma'am. Typing.
Okay.
Ma'am, could you scroll upward, ma'am? Not type in the third.
Load data set. Up, like down one or the up one? Which part you are on now? Manu?
Third one, ma'am. Third one.
Okay.
Data set part.
Okay. This one?
Yes, ma'am. Yes.
Okay. Okay.
కొద్దిగా స్క్రోల్ ఉన్నా.
Yes. Done, Manu? Are you here?
Yes, ma'am.
Okay. Basic pre-processing, are you done, right? Now just load the model. I can add here. Load, load, load. Word to wake from Gensim. Okay, so Gensim is the package for now that we are using. Okay, I hope you understand this point. I have shown you the examples for the fast text. Like these are also different packages. Okay, so you can they also have their own embedding models just like what to wake, so you can try it out those also. If time is there in one of the sessions, I can just take those also. Okay, so now this is load what to wake from Gensim, right? We are loading this what to wake model from Gensim package. We are giving the window size, sorry, window of 10, minimum count that is the two words, right? So ignores all words with total frequency lower than this. Now understand how it will work. If my sentence is left with only two words, right? After the window has been constructed, or for some reason only two words are there, then or only one word is left, so it will be ignored. Okay, that's what it means. So the minimum count of the words for constructing the vector or embedding for that particular word, we want it to be what? Two words, right? Now workers, this is again the based, you can just change it to two also, or based on the number of cores, right? So how many these worker threads to train, this is in response, this depends on your machine configuration. Okay, vector size, we know what is should be the dimension of each vector that we want to, sorry, each word vector that we want. And epochs is the number of iterations that we are doing. Okay, number of iterations exactly over the corpus. Okay, iterations. Okay, are these parameters in this particular function, are these clear, all these parameters?
Yes, ma'am. Yes.
Okay, then what we are doing, just write this, and then what we are doing, we are trying to build a vocabulary. We have seen in every even the previous frequency based techniques also, we have constructed a vocabulary. Why do we construct a vocabulary? Because we get the unique words, right? Just like any other dictionary, all the unique words will be there in this particular vocabulary. That's why we get the unique words from this particular corpus, because words will be repeated, so each word will be unique. That's why we have this build vocabulary. Okay, I can also execute, then build vocabulary. Now what is the count of this corpus? Now only 5,000 words are there, because I am using only one book. Okay, I hope this point is understood. Because we are only using one book, we are getting what word count as only 5,066. Okay, Manu.
Yes, ma'am.
Yes, let me know if you want me to scroll up. I'll just scroll up. Okay.
Okay.
Done, Manu?
Yes, ma'am. One. Yes, ma'am. Done, ma'am.
Okay. Epochs, this is just for your understanding that I have tried to show you. You can corpus count and epochs you can just forget, and then you have here train the model. Okay, train the model. Fine. So here we are training the model using this train. Just see how much time it is taking. It will take some time for you. Okay, just try running this. Write this particular thing. I can also write. Okay. Once you write this, if possible, please share your screen so that we all see that how much time this particular train function is taking in your system, or if it is happening on the go like within 2 minutes, that is also fine. Done, Manu, this line.
Hmm.
Have you executed this cell?
Yes, ma'am. First is cell I executed, ma'am. From fourth cell onwards, I getting a NLTK module error.
Mhm. 1 second, 1 second. Manu, can you share your screen?
Yes, ma'am.
Yeah, please share. I can just take. You should have told me, no, first only. I'll just stop and you can share your screen.
Actually, I don't have to permission for share the screen.
Ah, I'm giving you allow. 1 second. Now you should share, be able to share. Okay, so you are saying you are getting some error. Where you are getting the error? Okay, first executed. This is also executed. Wait, wait, wait. Slowly, slowly. Let the output come. Wait. NLTK module. No module name. Do you have NLTK? Can you scroll up once? So from NLTK, can you just do pip install NLTK? Is it not there, or you can just check once pip install NLTK? In our previous exercise, like notebooks, we did, but it might not be there. Just do pip install NLTK. Yes, because that. Are you not using virtual environment, or which you are using Jupyter notebooks, right? Anaconda.
No, no, I'm using virtual.
Okay, fine, fine. No, because your Python 3.10 kernel is same, no? That's why.
Actually, latest version of the Gensim package is not working, ma'am. Like 3.13 I used, ma'am, Gensem,
Uh-huh.
but it's not working. That's why I decreased my version. Like
Okay, okay. No.
it is asking to 3.12 below versions.
Okay, 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 fine, no problem. Now you go to that NLTK line. Is it not no module? Can you restart the kernel? What happened? Yeah, let it restart. Your screen is stuck, it seems. Okay, restarted. No, why you are executing that again? Restart. Just import, execute the gensim thing first. Yeah, can you just import that? Next cell, import OS.
Ma'am, I have to install import NLTK also, ma'am.
That no, that okay. If you even if you import, that is fine. Just check. You can just write in next cell. Just import NLTK. If our package is successfully installed, it should run. Create one more cell. Fine. Wherever you write, anything is fine. Import NLTK. Yeah. Mhm. Why it is showing yellow line? I don't know. Mhm. Why? Why we are not able to install NLTK? Okay. Can you just open your terminal? Go to these three dots after run. In your task bar, like above, where you have these files. Like, yes, exactly. I did in the same way. I don't know. Actually, your system is also stuck. It is. I did the same. You see, like that. Yeah. So can you just write pip here, pip install NLTK? Yes, NLTK. So you see, you are using the base thing, and okay, just execute that. So you see the first line, user Anaconda scripts activate. So this is your virtual environment, which is named as base. Okay, and NLTK. Can you just okay, close this? Okay, just press Control S, only press Control S and open your this complete, restart your Visual Studio Code once again. Just close the terminal. Yes, completely close. Have you saved your changes?
Yes, ma'am. Yes.
Yes. Let it close and then you try opening it again. Okay, can you just try again? Click on Python environments. Okay, you want Jupyter server. Okay. Yeah, what is happening? I'm not sure, yeah, for this thing. Okay, the first line that you have written, Manu, can you just give space between pip and exclamation sign? Minus Q is for force or for user? Dash Q?
Yes, ma'am. It's like a quite version. It's like we don't get any full
The
details of
okay,
installation.
okay, okay. But we are installing it. Why can't
May,
we?
I think maybe we are using the below. I think low version. I thought that is the issue. I think so, ma'am.
Okay, but
Let Can I try the 3.13 for the NLTK? Like,
yes,
uh,
okay. What you do? See, I have also seen what is my version here. Let me also check. I can tell you after that. So mine is 3.11. Wait. So what you can do? Can you just, yeah, open that Python 3.10? Click there. Can you select the base or another kernel? Okay, select another kernel. What kernels you have? Can,
3.13 and 3.10, ma'am.
okay, you have only these two.
Yes,
Mm,
ma'am.
3.10 is too low. I'm not sure what's.
Uh,
So you are
within
saying
10
we can
within
use.
10 minutes, if possible, if 10 within 10 minutes, I will install, ma'am.
Oh, no, no.
3.11 version.
Okay, no problem. You can do it later. For now, let me just tell you what you can add. Wait, instead of NLTK, we will add another line. Okay, don't worry. One second, I am telling you. Okay, don't worry.
Yes, ma'am. It's like using the low version is the issue, ma'am. If I use 3.13, it is working.
It is working great, but you have a Gensim in that.
No, ma'am. The 3.13 Jensen is not working.
Can you just install that quickly?
It's like Jensen, ma'am.
Can you execute this second cell, the import Gensim, import OS cell?
I think it's not going to work.
Just check. If it is not installed, we will install. Gensim is not there, na fine. Now instead of just write there import Gensim, I will tell you. Wait. What to wait? Just use this one. Wait. This thing. Just try this. I have pasted instead of exclamation. Just use percentage. If it works, I don't know. Yeah, let it install. It is taking time. Let it take. No problem. At least one should have working thing for this particular part. is taking too much time. Yeah?
Yes, ma'am. Last time installing it like taken almost 20 minutes.
20 minutes. Okay,
Yes, ma'am.
let me install. By that time, please write another code. You can stop sharing your screen. Let it run. Don't run the cell. Okay. So just try from where. Don't run the cell. Okay. I hope you understand. Just copy the code from the screen. I will. You can stop sharing your screen. Okay. Then once you are done, don't stop. Also, let that cell run. Just stop presenting your screen, let that cell run. By that time you just copy the another codes. Okay,
Okay,
don't
ma'am.
don't run the cells. Yeah, okay, now I will share my screen. Okay, and so you just check where you left off in the Harry Potter what to wake, right? So we loaded and then we were on the train, right? Train. So just write this train from here. At least if you are able to write most similar also, then we are good for the day. I can just explain a few more next steps that we will be doing. Are you here, Manu?
Yes,
So
ma'am. Yes, ma'am.
yeah, just you just wrote this line if I remember. Just write few of these. I
Yes, ma'am.
can
That line also completed. Yes, ma'am.
clear cell output, clear cell outputs. Okay, so you can just write one of these. This is for just for your understanding. Okay. Done, Manu?
Ma'am, could you scroll upwards, ma'am? I think I missed the one line.
And that is fine. See this, if you have written this most similar function is just like I'm calling it with different words that will give me the related words to that particular word.
Okay, ma'am. Okay. Done.
Yeah, then similarity will give me the similarity score between Harry and Dursley. Okay, okay. Then if you want, you see this now it is giving us that much score. If I execute Ron, it is giving me this much. Okay, now so get vector. This is dot shape. You can just remove this. Okay, so this will give me the vector for Harry. Our vector was of 100 dimension, right? And normalized vector. Now if you want, what this will do, it will give us the L2 norm for all the vectors that we have created. Okay, so if you see now what has happened, now all the embeddings have been converted into some this L2 normalized rows, right? So if you see, get all the, yes, so Euclidean distance. So this is based on the Euclidean distance. Now this particular normalized vectors to we are going to use for the representation of the 2D or 3D vectors, right? So if just check this, just write this part from here, you can write, Manu.
Okay, ma'am.
Yeah, y is equals to model that dot what to x dot index to keys. What this will give? This will give me the list of all the unique words from my vector.
Yes, ma'am, done, ma'am.
Okay, now you know this why. Just write this. This is the last thing that you have to write. Okay. Do you have sklearn module installed?
Yes, ma'am,
First,
already installed.
okay, you can just write this and we can check.
Yes, ma'am, done, ma'am.
Done? Okay. Now you check if your Gensim package has been done or not. Installed? Is it installed? You can share your screen because this is the last other plotly and that you can write on your own. That was just I showed for the sake of like visualization. I hope you understand that. Is it installed? Your
No, ma'am,
Gen.
it's still installing.
Okay, is it still installing? Fine, no problem. Okay, okay, I can share back. Fine. So this way, what we have done, we have tried to train a word to wake model on our own custom data set, right? Manu, I'll give you 15 minutes more. If that is done, just let me know. Okay, that installation.
Okay, ma'am.
Yeah. Now, this way we have trained our model, right? You on our Harry Potter data set. Now you just see how many more epochs or the window size. Try playing around with these particular hyperparameters, the vector size, and see how good is your embeddings created. Because still there is, if you see Ron and Harry and Dursley, right? They have some like very near to each other, but ideally Harry and Dursley, though they, this indicates what, these are coming these are in the sentences of the book, these are coming almost many times in their sentence, right? Like Harry and Dursley are coming together in sentences, that's what it means, right? So it might be the case in this particular book, but book 3, book 4, book 2, all for this it might be a different case. So just see how many iterations you have to train that particular model, and how is the accuracy of this particular similarity vectors. Okay, now this is till the phase where we have learned the pre-processing, the word to x, and also training the word to x model on our own data set. Now moving forward, what we will be going to start is the text classification. Okay, so now what is text classification? So text classification is nothing but where we are doing some classification problem. It is a task of assigning one or more categories to a given piece of text. We in machine learning problem, right? In machine learning, we have a classification problem, right? Now, what does that mean? Classification, given a set of, let us say, features or any data set, we try to assign some label to that particular uh, thing, right? If let us say if it is a male or female or something, right? If it is a cat or dog, based on the features, these are the classification problems. Now these classification problems can be performed on textual, speech, or image data, right? If you have image, it will be doing classification for, let us say, images of cats and dogs, to whether the image belongs to a cat or a dog, something like that. For text, how does it work? It works in the same fashion, just that instead of image, we have some textual data, right? So if you see, what does the say in machine learning, classification is the problem of categorizing a data instance into one or more known classes. The data point can be originally of different formats, just like what I said, it can be text, image, speech, or numeric, right? Now when it comes to text classification, what it has, we have a textual data, right, where the data point is text, and our goal is to categorize that piece of text into one or more buckets. Into we need, what is our task? Our task is to assign a label, right? A label, here a label can be also called as a class. Assign a label or a class from a set of predefined class. Now if you see in the right, we have a text spam classifier, whether sorry, email classifier. What is that? Whether an email is a spam, or if it is a not spam. If it is a spam, it will go in what? In the spam folder. If it is a normal mail, no, not a spam mail, what, where it will go? It will go into the inbox, just like it happens in our mailbox. Now this is a classic example of what? This is a classic example of text classification. I hope this point is clear. Right now, a text. Now, what is this paragraph saying? A text can be of arbitrary length. We already have seen length of what? Variable, character, word, or sentences, or it can be a full document. Like in our example, we had a corpus of Harry Potter books. Harry Potter books, right? All these data. It was on what? Harry Potter's book. All the series data, right? Now, so we can have any other document also. What we had was a document. Instead of paragraph or sentence, we had a complete document on of that book, right? Now here what we can do, we can have few more examples. Like we can just go to some reviews, website reviews, and there also we can do a sentiment analysis, where we based on the reviews, we are categorizing whether the users are having a positive sentiment towards it, or a negative sentiment. Okay, so this task also comes under what? This task also comes under text classification. Now I hope at this point what is text classification is understood. In machine learning, classification is nothing but categorizing a data point or anything into a known class, right? Here the data point can be of any format. It can be a text, speech, image, right? Now particularly text classification, since we are dealing with textual content right now, So what happens in textual content? What context we have? Text as a data, and we have to classify it into a known buckets or classes. Okay. Now any supervised, what does the slide say? 1 second, let me. Okay, any supervised classification approach, including test classification, can be further distinguished into three types of classes. What are those? Binary, multi-class, and multi-label. Now these are the different types of classifications. Now what is a binary classification? Binary classification is where you have only two types of classes, which is either 1 or 0, something like that, whether if it is a spam or not spam. So this particular example which is there of email classifier, that is a binary class classification, wherein we have only two classes, which is saying binary means nothing but two, right? So the class number of classes will be two. Either it will say it is a spam mail or it is a not spam. Okay, so if the number of classes is 2, it is called a binary classification. Now once the number of classes increases from 2 to more to from 2 or more, what happens? That is a multi-class classification, right? So what is a multi-class classification? If the number of classes is more than 2, then the classification problem becomes a multi-class classification, right? Now after that, what it is saying? Yes, same. The problem of classifying an email as a spam or not spam is an example of binary classification setting. I hope this is understood now. The same, the email, the review sentiment analysis or any kind of sentiment analysis is a multi-class classification. Why? Because there we have three classes: positive, negative, or neutral. That's why classifying the sentiment of a customer review as negative, neutral, or positive is a form of what classification? Multi-class classification. I hope it is clear till here, everyone.
Yes, ma'am.
Okay, now we have understood multi-class and binary. Now what is multi-label classification? Now multi-label, now it might happen that a document can be of more than one class, right, at the same time. So if you see, for an example, understand, a news article on soccer may match to may belong to more than one category, such as sports and soccer simultaneously, whereas other news article on US election may have labels like politics, USA, and elections, right? So what it is saying, we have a document, news articles, right? I have a newspaper, and in that newspaper there are different types of classes: sports, soccer, USA, politics. So in the same document, what is happening? In one article I can have 2 3 classes labeled, and that particular document or article is belonging to more than one class. That is where it is called as what? Multi-label classification. In the same article there are 2 3 classes that it can be classified to. So at that time, what do we say? It is a multi-class multi-label classification. Is it understood the difference between binary, multi-class, and multi-label classification? If not, let us see pictorially. Okay, you see three types of classification tasks in the picture. If you are able to see, sorry. Okay, binary classification, whether an email is a spam or not spam. Multi-class, now in this image, what is the one label that we can classify it to out of others? It belongs to dog, right? Now multi-label classification, now in this particular image, what you can see, there is a cat and there is a bird also. So this is a cat also, and it belongs to, it has a bird also. That's why it is a multi-label classification. Okay, another example similar to this multi-class classification, this belongs to dog, so that's why the probability of it being a dog is 0.7, right? 0.1 for cat, 0.1 for horse, and 0.1 for mouse. That's why one class is getting ticked. right? That's why this is a multi-class classification. Now if you see the other image where we have multi-label classification, what does it say? It has a dog and a cat in it. So dog 0.8, cat 0.8, others are lesser than that. So that's why the probability of two classes, the dog and the cat, is more. That's why it is belonging to dog and cat. Okay, this is how the classification types are there: binary, multi-class and multi-label classifications. Now moving forward, we will see different types of application in this particular classification, text classification problems. A few are there. It can be used in content classification, customer support and e-commerce, right? So same, e-commerce is nothing but understand the customer's perspective for the product based on their commits. Customer support, social media, customer to express their opinion and experience about the products and services. Same, these are few widely used application. Now what we will do, if you remember, we have seen the classic pipeline of our NLP process, right? This is our NLP pipeline. So in this pipeline we have also seen few more things like the ML, machine learning model, the heuristics based models, right? So moving forward, we will try to go into the details of how do we do the text classification things. Okay, is this understood? We will go one more round of NLP pipeline and we will start implementing the bag of words, the TF, IDF and other things in practical scenarios. Okay, is this understood, everyone?
Yes, ma'am.
Manu, is it done for you now?
Yes,
Just
ma'am.
check.
Yes, ma'am.
Yes, now can you just share your screen quickly so I can just see if it is working or not?
Okay.
Yeah, please share your screen. I'll just check. You need to restart the kernel. Just restart your kernel. Yes, now you can import, quickly execute it. Okay, what is the error? What is that error? Can you just NLTK data? Return sentence, okay. NLTK recommended parameter language, tokenizer load. Hmm. Can you just scroll up once? Tokenize, top sentence, tokenize. I think I had that this punked model. I directly, wait, I will send you that line if it works. Let us just see. Otherwise, just try resolving it. Otherwise, just mail me over this. Okay, I'm just sharing you my mail.
Okay.
You can just note this UP99. Yeah, this is my mail. Just ping me if you are not able to resolve. I can just share 1 second. Mm. You can just execute this one time. I have shared the input NLTK. After that, few imports are there. Just check in the chat.
Yes, ma'am.
Yes, just execute, run that cell. Okay, 20 epochs, will it work on your system? Okay, let it be. Keep 10 for now because I don't know if it will, how long will it take? Oh, okay. Just execute that. Great. Corpus count. Okay, you are using all the three books data. Okay, fine, fine. Let it be. No problem. We will see how much time it takes. Yes. Yeah, it will take a while. Let it execute.
In meantime, I installed the 3.11.5 version.
Oh, you already installed 3.11. Okay, great, great. Ah, it got trained. Nice. Now, yes, model dot, yes, execute this. Great. Rowling, layer, stone, grave, griffin, cannon. Yes, type Dursley. Can you just type yes, Ollivander, Morris. Okay, one more word. Can you just type here? Just copy this complete line for this one. Yes. So what was the spelling of Azkaban? Just see Azkaban. What we get as Azkaban. A-Z-A. Sorry, Azkaban. Azkaban. Just type this. Yes, yes. Just print. See, prisoner. Prisoner, page, secrets, philosopher, chamber, stone, potter. You see, all these words are coming near to Azkaban. So these have, what does this indicates now in the corpus, whatever we are using. So since you have used all the three, right? The third one is mostly the prisoners of Azkaban. I don't remember exactly, but this prisoner, secrets, all these words have been constantly coming around or in the context of this Azkaban word. That's why we are getting this as their most similar words because their embedding is very much similar to the Azkaban embedding. I hope you understand this point, Manu.
Yes, ma'am. Yes, ma'am.
Yes. Now, can you just scroll down? Yeah. Scroll down more. Yeah, you can execute this similarity also. The model dot similarity. So this will give us the score, only the score. What happened? Yes, you see, Dursley and yes, execute the other one. Yeah, so see, now you see when we have taken all the three books, the similarity between Harry and Dursley is lesser than the similarity of what? Harry and Ron. You see? Yes, just execute the Y thing, Y cell. Yes. So you will just see the next Yes. Next cell, the visualization. Yes. Do you have sklearn here? If I don't think so because it is showing yellow, but just download it and you will be able to get the visualization. Also, I would recommend you to what play around with all of these things so that you understand it more clearly. Okay.
Okay.
Yeah. Minus q sklearn, but it should be skykit learn. No, just check. Add the exclamation or symbol. I can share you if you want. You can use this Manu I am sharing. Pip install skykit dash learn. Okay.
Hello, ma'am.
Yeah, yeah, I am here. Tell me.
Yes,
Uh,
ma'am. I got the.
but why your vector is these many points? I'm not understanding. Can you scroll up bit? 16, 40, 40. The number of points you see here, if you remember my I think somewhere you have just added all the points. I think plot that scatter x colon 0. Then, okay, enumerate where is x? Yeah, xy xi of 0. Okay, fine. Just check it. Whole point is like how do we have a visual? Try using Plotly also. You can use the generate mode as you already have to see the 3D visualization also. Okay. Okay, Manu.
Okay, ma'am.
Yeah, thank you. Thank you so much for sharing your screen and writing the complete code. It feels good to see your efforts. Okay, just let me know if you have any doubts. I have given you my Gmail ID. If you
Yes.
want, you can ask any doubts there. Okay.
Okay.
All
Okay,
right.
ma'am.
In the next session, we will learn few more things about text classification. Okay. Just try
Okay,
to
ma'am.
revise everything. If you have any doubts, next class, if you want, we can do a quick revision of all the things that we have covered and move forward. Okay. Or if you have any specific doubts regarding any specific topic, I can cover that also. Okay.
Good. Good.
Okay. Thank you. Thank you, everyone.
Thank you.
Yeah. See ya then. I'll drop the session.